Take a look at this problem and see if we can't solve it. We'll see what happens, huh? All right, for the function, find the points on the graph for which the tangent line is 0. Tangent line is 0 makes me think that we need y prime to equal 0. So I need to find that somehow. How am I going to find that? First thing, let's find the first derivative and see what happens. We can use the power rule. That's helpful. So the 3 comes down. We have 4 thirds times 3x squared minus 5. Looks okay to me. Cancel the 3's. That looks cool. 4x squared minus 5. Okay, I need to see what is the x value where this goes to 0. So again, where does y prime equal 0? X equals plus or minus square root. 5 comes over divided by 4. And then that's going to be plus or minus 5 halves because we can take the square root of 2 on the bottom. So it's plus or minus root 5 halves. Okay, now we have to plug that into the original function. So I'm going to change colors so we can see that I'm changing ideas, but I'm going to plug both of these numbers in the original function and see what the output is. So y equals 4 thirds negative root 5 halves cubed minus 5 negative root 5 halves plus 3. What do we get? 4 thirds. So negative root 5 to the third would still be negative. You're going to get a 5 out of it because of the square. Then you'll still have a root 5 there because it's 3 times. And then 2 to the third is 8. And that looks like that can reduce. And I'll just leave that for another step. 5, negative 5 times negative is positive. It's going to give me 5 root 5 halves. And then I still just have a plus 3 over there. I have 4 over 8. And the 8 gives me a 2. Negative 5 over 3 doesn't seem to reduce. So I'm going to write this so I have some room for the second part. I think this would be negative 5 root 5. 3 times 2 is 6 plus 5 root 5 halves plus 3. I think that's the output if you plug in the negative. Does the computer agree? I think so. Yeah, I think that's the same. Okay. Let's change colors and plug in the other one. Okay, so let's plugged in the negative. Let's plug in the positive and see what happens. 4 thirds root 5 halves cubed minus 5 root 5 halves plus 3. Okay, similar, but don't have to worry as much about signs. So root 5 cubed would give me a 5 and a root 5 over 8, and we can see we're going to reduce there. 5 root 5 halves plus 3. So 4 over 8 gives me 2. 5 halves doesn't reduce. 3, I don't think reduces there. So 5 root 5 over 6 minus 5 root 5 halves plus 3. I think that's the output if you plug in the positive Yeah, I get the same thing. So if you want to see it as a final answer, usually, you don't have to, but usually I plug in the -1 first, comma, -5 root 5 6 plus 5 root 5 halves plus 3. So that's one of the ordered pairs. And then the other one is root 5 halves 5 root 5 over 6 minus 5 root 5 halves plus 3. Okay, save a screenshot in case anyone else is interested. And yeah, I hope that helps.